you all for having me. I'm really excited to be here, really excited to be at this conference, to be here in the United Kingdom, and to kind of take a break from my country and my president, if you know what I'm talking about. But, well, actually, now that I think about it, I do want to be let back into the country, so never mind. Pretend I never said anything, all right? But I have, I tweeted out a link to my slides, so if you go to my Twitter account, BenMVP, you can find a link to these slides. I like to include lots of links in my slides, so if you want to follow along, if you see something interesting, you can have those to check out, or you can go to my website, benmvp.com, to see it there. But what I'm going to be talking about is Isomorphic React without a Node web server. And just to kind of put things in perspective or tell you what we're going to be talking about, I won't have the time to talk about why to use React or how to build React applications. I will be showing some React components and React code, so I'll do my best to try to explain what they do if you're not familiar with React development. But I will, like I said, be talking about Isomorphic React without a Node web server. So what Isomorphic React is, or Isomorphic JavaScript, is the concept of displaying or rendering on the server using the same templates that you use on the client side. So you don't have to duplicate your UI code. What you're rendering on the client in the browser with your React components, doing the same thing on the server. So also one other thing to kind of tackle is this concept of isomorphic JavaScript versus universal JavaScript. So the phrase is normally isomorphic JavaScript, but people have been pushing for calling it to be universal JavaScript, because isomorphic doesn't mean what we think it means. Basically, isomorphic means that two things look the same, but they're actually different. Whereas universal means that something that's applicable everywhere. So technically, we should be calling it universal JavaScript, or we should be calling it universal React. But I still prefer to call it isomorphic React because I think it sounds cooler, right? And I actually think I sound smarter by saying isomorphic React. I built an isomorphic React application, ha ha ha, right? So I'm still gonna stick with it. You can call it universal if you like, because it's more correct, but I will be saying isomorphic React. And now, one thing I like to do at the beginning of talks is to kind of loosen things up. So if I can get everyone to stand up, I want everybody to stand up in your seat, everyone to stand up. We're gonna do some light exercise, okay? So we're just gonna do some squats like this. You're gonna bend your knees and put your arms out like this, okay? So if you're unable to do the squats, by all means, do not feel bad about that. Just go ahead and stand. But we're gonna do 10 squats in unison together just to warm up our bodies, okay? And to feel quite silly, all right? So let's do it. Ready? 1, 2, 3, looking good. 4, 5, 6. You're feeling that burn, aren't you? 7, 8, 9, and 10. Great job, everyone. All right. All right. What? Before you sit down, turn to your neighbor, introduce yourself, and say hello. All right. Okay, now you can have a seat, please. Have a seat. So now that you've introduced yourselves to one another, I want to introduce myself. So like I said, my name is Ben Ilegbodu. I'm a Christian, a husband, and a father of 2 girls. That's my wife, Rashida. We've been married for 6.5 years or so. And our oldest daughter, Simone, she's 3 years old. And our youngest daughter, Avery, she's 7 months old. And I'm not quite sure why my youngest daughter is giving my oldest a side-eye glance in this picture. They really do love each other, but I guess that's what came about. So like she said, I live in Pittsburgh, California. It's a small town outside of San Francisco, about an hour away, and I made the journey all the way here, so I'm really excited to be here. I work at Eventbrite. So for you guys, for anybody not familiar with Eventbrite, we're an online ticketing and events platform. I actually noticed that Render is using one of our competitors for their tickets, but no harm, no foul. It's okay. It's okay. But I am the manager of our front-end platform team. So over the past year, we've been spending time migrating our front-end stack from Backbone and Marionette over to React. And one of the key portions of that transition is that we had to be able to render our React components on the server. And that's Isomorphic React. And the reason that's important is because of performance, SEO, and then open graph tags. So from a performance standpoint, if the UI is rendered on the server before it gets to the client, it'll render faster in the browser. So you don't have the situation where you get a blank white screen and then you download all of the assets and then finally render on the client. If it's rendered on the server, the user gets something immediately when they visit the page. And then from an SEO standpoint, obviously it's rendered on the server, so all of the crawlers are able to get that data. Crawlers now are able to actually process JavaScript, so they can see what's rendered on the client, but they bring extra weight to websites that are rendered quickly. So server-side render also affects that. And then lastly, open graph tags. So when you share something on Twitter, when you share something on Facebook, they go and pull different information from the source code of your site. So being able to have those tags server-side helps with that as well. So we're talking about the initial render of the page. So after the page is rendered and you have your single page app and you have all the interaction, all of that is happening on the client. It's just that initial render. So Node is needed to be able to render JavaScript and execute JavaScript, right? So that's what we need our server to be, in Node. And typically you will have an Express server maybe, and you will include a library like React router that will do all the routing for you on the server side, and you kind of combine those together, and you would execute your React component, render it out to a string, and then include that in the server response. But since Eventbrite has been around for 10 plus years, our backend is not in Node, our web server is not in Node, it's actually in Django, written in Python. And obviously, Django or Python cannot interpret JavaScript. It interprets Python. So the question is, how do we render our React components on our web server when our web server is in Django and Python? Does anybody else use Python, Django? Anybody else familiar with it? Okay, we got a number of hands there. Yep. So currently we've solved this kind of dual rendering issue by using a library called PieBars, because all of our JavaScript was written in handlebars. So this library takes the handlebars files, processes it, and converts it into Python functions, and then those Python functions return strings, which we can then include in the server response. So that's worked fine. The library was kind of poorly written, so it was super duper slow to actually do that translation, but it still worked. So the problem is that the same solution wouldn't work for React, because essentially we would have to take our Python or Django would have to interpret all of JavaScript. We basically have to have Node inside of Django. And we thought about doing that for a second. What if we had V8 and included that in there? But that wasn't really a feasible idea. So, but this problem is not just specific to Python and Django. It's any kind of backend. So if you have Ruby on Rails, any Rails developers here? Yeah, Rails. If you have PHP, anybody with PHP? Yeah. ASP.NET, how about that? ASP.NET? No, okay. Well then, I see how you feel about .NET. How about Java? Any Java developers? Okay. Any Cold Fusion developers? What? Okay, we got 4. Wow. Wonder what apps you guys are building. When we've tried to switch actually to Node backend a number of times, and our ops department was basically like telling us, no, you can't do it. Every time we tried, they were like, no, don't do it. And not because Node and Express are bad inherently, it's just that they were completely unfamiliar with Node. They've been doing Django and Python for a long time. They're used to how to monitor a Django app, how to debug it when something goes wrong. And they didn't have that experience with Node. as front-end developers, we're very familiar with Node, but our ops and our backend teams weren't familiar with it. So that became a problem. And we also have this kind of monolithic legacy Django app as well. So making that transition over to Node, we have to port all of that legacy stuff, which wouldn't be that great. We are service-oriented, but we still have a lot of stuff still in that kind of ball of mud. So we didn't want to have to replicate all of that logic. And in theory, we were already making a huge gamble going into React. So moving our web server over to Node would have been a gamble on top of a gamble. So we're at this point where, on one hand, we knew that our web server could not change from being Django and Python because ops needed it to be so. But then on the other hand, we need Node in order to render React components on the server side. And so we had these two things. We were trying to figure out, what do we do? And we were thinking about it, and we were thinking about it some more. And then we were still thinking about it more and more until finally we got it. And we decided that we would have both. We would have our Django server and our Node server together. And actually, it was more so having the main Django server and this little tiny Node server with it. So I'm going to kind of walk through the pseudocode of how we architected and set this whole thing up. So what we ended up creating is what I call a stateless render server. So what it did is that we would pass in a path to the React component, as well as the props that kind of configure that React component. And what it would return back is the generated HTML. So that's all it did. It didn't make any AJAX requests. It didn't make any DB requests. It didn't make anything, any kind of side effects. It took in those two properties, the URL and the props, and out came out the HTML. So I'm calling it stateless because it still had access to the file system in order to load the files, the JavaScript files. So that was kind of state, but for the most part, it was input, output. So let's take a look at this sample React component. It's a hello world component, and it takes one prop, which is the name, and out it returns a div that says hello name with an exclamation point. That's all the component does, and we'll kind of walk through what this would look like. So here we have a curl request. So we're passing in a header, thanks to HTTP 1.1 is what I learned earlier, I think. Yes, we pass in a header that says that the content type is JSON, and then we do a post, and we pass in that data. So that data has a path to the hello world JSX file as the path, and the props has the name bin, because I just chose my own name. And then we go to the URL, which was localhost on the port 9009/render. That's the URL we're going to. When we make that curl request, this is what we get back, that HTML. So that's an example of just what the stateless render does, input, output. So a kind of high-level view of what the Express server looked like is we had a server.js file. It would expose a render route, and it would take in the request. And remember, the request.body was JSON that had the path and the props as two parameters of it. So with the path, we would do a dynamic require. So we would require the path that was passed in. Normally, you just require some static path that you have locally, but we're requiring a dynamic path that was passed in, and that will give us a reference to the component class for the React component. Then, taking that component class, we would combine it with the props in order to create an actual React element instance. So using React.createElement, we would pass in that component that we just dynamically required, take the props, and get back the instance. And now we have the element. And then lastly, using React's render to string, we're able to take that instance, render it out to an HTML. And that's one of the cool things about React is that it actually exposes a method, a function that will render out to a string. Most JavaScript libraries just assume the browser and assume that they're mutating the DOM, so they do the DOM mutations, and you actually have to have access to the DOM. But since React is just about declaring your user interface and you can render out in different ways, one of them is to string. So that was the last one. We'd get the markup, and then we would take it out to the response. So kind of those 4 steps are the process from going from path and props out to a string, and that's all the server did. There was more details in there. Obviously, when you're trying to make production code, you have to add in lots of different details, but at a high level, that's essentially what it did. So we would run the server this way using Node. So Node server, and it had a verbose flag there, and it would start the server, and then any request that would come in, it would serve that and return the HTML for that component. So on the server side, the Django side, we would first get all of the data that we needed to pass in as props. So we would make the DB requests that were necessary. We would make any SOA calls, service-oriented calls, anything that we wanted to process from the get or post params we would get together, any other environment parameters like the language, the currency, all those things we would get together in a variable. Here I'm calling it component props. And then we would pass that in as the props that we would pass to the component. So we would do a request.post to the URL that's predefined for the render server, pass in those headers, like I said, to mention that it's JSON, and then send that out. And then in the response, we would get back the text from that response and put it in this, I guess, environment variable, context variable, that we could then use in our HTML template. So we still had to have, even though we're rendering completely server-side with Node, we still had to use some Django, and here we're using a Mako template for the scaffolding. So that defines the HTML tag, the body tag, and then we would stick the response from the server into a div tag that was the app. So that React page markup variable, that was the whole entire HTML that was rendered from the server. And then below that, we would include the script tag that would have the bundle.js, so all the JS that was needed to render the page. So hopefully when you're looking at this, you're wondering, well, isn't there network overhead, right? Instead of just rendering server-side, now you're making a request to this other server that's going to do some processing, and then it's coming back with the data, and then you're rendering it out. There's that extra round trip. Isn't there overhead? And the simple answer is yes, there definitely is overhead. But we tried to mitigate it as much as possible. So first, the Django server and the Node server sat on the same machine. So there was only so far that the bits had to go in the round trip. And then secondly, we tried to limit to only have one React render request per page view. So we were trying to render out a whole entire page instead of just one tiny component. Like, we didn't want to use it for just one button on the page. We wanted to render out the whole entire page. So there was a one-to-one mapping so that we only had one extra round trip. And then we also found that this overhead of making this round trip to get the page into rendering it was actually still slower than that PieBars solution that I mentioned. Because that library was so slow in how it processed handlebars templates that making that round trip, rendering in React on the server was actually still faster. So in the end, even though there was network overhead, the solution or the result was that our pages were rendering faster and when we're doing tests that way. So we actually ended up speeding things up by making the transition over. So that was basically it. That's how it worked. That's kind of the overview of how it worked. But as you know, when you're doing development, the proof of concept is easy, but then actually making it production ready, everything is not sunshine and roses, right? There are always issues that you run into. And if you're in the same situation that we were in, hopefully what I've explained kind of has given you direction into how you can implement it, but you're gonna run into your own kind of pitfalls, as you may. So I wanna kind of show you some of the pitfalls that we went through so that you can navigate and jump over them. That's what this is trying to show, jumping over the pitfalls. So the first issue that we had, it was in development, you want to have on-demand transpilation. So you're writing your JavaScript, your React components, and new ES6, ES 2015, and beyond syntax, you're also using JSX syntax, which the browsers don't support fully yet. So you need to transpile that code into ES5 that the browsers can support when you're developing. So in production, you would, as part of your build process, do all of that and then ship in a bundle the ES5 code. But when you're developing, you don't want to have to transpile as a command all the time. You want it to happen as you're doing it. And the first issue that we ran into, obviously, is that the server didn't support that. It assumed that everything was already transpiled. So we got this error saying unexpected reserved word import, because it wasn't expecting that. So the first thing we had to do was do on-demand transpilation. And the way that we accomplished that was using a CLI that wraps a node called Babel node. And what it will do was automatically transpile anything that was required inside of it. So if you required something that had ES6, it would transpile it to ES5 on the fly, on demand, which was great. So we solved that first problem. Then the second problem was the fact that when you do the dynamic require, or when you require in general with Node, it caches that reference. It doesn't always go back to the file system to get a new reference. It caches it so that each time you require, it's a lot faster. But if you're doing development on a component and you make changes, you don't want it to have that cached value. You want to invalidate that cache. And there are a lot of hacks that you can do to make Node invalidate its cache, but they all have these problems. So what we ended up deciding to do was to just restart the server every time a file changed. So we would watch for a certain directory and then restart the server. So we used a library called Node Supervisor to do that. But the problem is that when we restarted the server, Babel node would crash, basically. And when it crashed, it still had an open port that it was running on. So when supervisor took down the server and tried to bring it back up, it would say that the address was still in use, which was a problem. So kind of racked my head around it, did a lot of Stack Overflow searches, tried to figure out what people did with this problem. And in the end, I found this require flag that's on Node. So what that tells it is that before anything is required, you can run it through this other library first. So I ended up using the Babel require register hook. So it works much like Babel node in that it will do a transpilation for anything that gets required automatically in Node. So when we do that dynamic require for that component, on the fly, it will get transpiled. And even though it works very similar to how Babel node does, using the register hook made it work, basically. So now when supervisor restarted the server, took it down, brought it back up, it was actually able to start. So that was one problem, or that was the second problem, basically. But then there was another one that we ran into. So I was developing this on my Mac, and everything worked fine. But then the second I put it into our Docker environment that runs inside of Vagrant, it would never actually restart. I would make the changes, it was supposed to be watching, but nothing ever happened. And the reason is because Docker inside of Vagrant is running on NFS. So I didn't know this, I had to be told this. And as a result of NFS, there's something called the iNotify that exists in Mac that doesn't exist in NFS. So whenever a file changes, there's no notification that says the file changed. So as a result, instead of the way that I was using it before with supervisor, I had to do something called long polling. So here I'm polling for every 5 seconds the whole file system under this directory tree to see if anything has changed. So it made the server less responsive because I'd have to wait at least 5 seconds until the change was reflected, but it was the only way that I could make it work. So there is Docker, there are like 3 versions of Docker. There's Docker inside Vagrant, or Docker machine, and then Docker for Mac. And ideally, if we switch to Docker for Mac, which will just be running directly on our Mac file system, then we wouldn't have this problem. But that's something that's completely out of my scope and out of my element. I have no control of our Docker environment, so we went with the long polling. So if you're using Vagrant, you may have the same issue. Another problem that we had was the size of our node modules. So when they were installed, our node modules was a whole gigabyte of node modules. We're running on NPM2. And this was never a problem before because we were never rendering anything server-side. So before we deployed everything to our production machines, we would delete all of our node modules because we never needed them server-side. After the bundles were created, they would have all the necessary node modules, and the server never needed those node modules. But now that we're rendering server-side in Node, obviously we need them. The thing is that most of the node modules were just around grunt and dev dependency type things. They weren't anything that we were using in production, but they were still really big and we had to copy everything over. So that was slowing down the deployment process because everything had to be transferred over. So once we switched to Yarn and that had deduping, we were actually able to go from 1 gigabyte to only a couple of hundred megabytes because there are a lot of duplications in our node modules. So the flattening out that Yarn or NPM3 will give you helped us with that situation. So then there are a lot of other things that we had to do to get it to production. This is like what I've already described was already a step out of my element. Like I'm a UI engineer. I build stuff in the browser. I build user interface components. Doing all of this Unix and Linux server-side things was already a stretch, but we had to do even more things. And this is where other team members came in, backend engineers came in to help me with this. So we had to do a ping endpoint to make sure that the server was always running. It's an obvious thing. We had to do logging, Sentry error logging, performance monitoring, load testing, like all of these different things were necessary in order to make sure that it was production ready. But I'm happy to report that this server that we built is actually running in production right now. So if a different conference that was using Eventbrite, let's say, was running, then our checkout widget, where you actually pick your tickets on the conference websites and check out, that's all running with this new application that we built. Because with this transition over to React, we decided that we wouldn't convert existing features, just new features that we're building would be on the new platform. So that was one. We have one that's in beta right now, a whole new event creation experience that we're building. That's there, and then a new login flow. So we have those working. So when we were actually trying to figure out this whole solution, we looked around and tried to find something that was already doing what we were doing, and we didn't find anything that was doing it. This was, I think this time last year we were looking for it, and we couldn't find anything. And then shortly before like last October or so, I did a look and saw that Airbnb had something called Hypernova, which was basically the same implementation, just built on top of Rails instead of built on top of Python. And I was planning to open source this React render server that we built, and there would have been all this hoopla, and I would have been showered in glory, and it would have been so awesome. And then just realized that Airbnb had stolen my thunder 3 months before. So it was unfortunate. But if you're using Rails, Hypernova is a great open source tool that you can use that does a lot of what I just described. We're using these two libraries, Python React and React Render, in order to accomplish some of the things that I talked about. There's also React.js if you're in .NET and you want to render React components, or in Java there's a Nashorn runtime, JavaScript runtime. So to close, I wanted to give a couple of shout outs. I wanted to shout out the Render Conference and all of the organizers for inviting me here to be able to share with you. So I really thank and appreciate you guys, Ben and company, for having me here to share our experiences and what we've learned. Also want to thank Eventbrite for allowing me to come here. I'm not a developer relations person. I'm just a manager who's had experience with developing things and wants to share some of the things that Eventbrite has done. And they're very supportive in me coming out and sharing in different conferences. So I really appreciate that. And then lastly, but not least, of course, thankful for you for listening in. And one of the main reasons why I do this is that I hope that you leave different than before. when I was talking, so hopefully you learned something. Maybe it was related to the topic or something on the side, but hopefully you're a better developer as a result of listening to me talk. So if that is the case, I really hope it is. If it is, please let me know. And if it wasn't, you can also let me know gently as well. But with that, thank you very much, guys.